Hello there. We'll be looking at the solutions for the motion part, the motion in a straight line and the motion in a plane in this video. It would be 30 questions. It's CET format. Let us check how quickly we can solve each question because it's the rule of the game. It's 1 minute per question. So here we begin. The very first question, horizontal range is 4 to 3 times the maximum height. Wherever and whenever you see the wording between range and height in projectile motion, we always go with h by r equal to tan theta by 4. And now what you do is you put the range as 4 root 3 times h. The heights cancel on both sides, the force cancel on both sides, and we have tan theta to be 1 by root 3. So tan of what angle is 1 by root 3? We ask ourselves and we get the solution as 30 degrees. Here we go. Next one. Body of mass m is projected with the speed u and an angle alpha. They're asking the change in momentum. Well, the extra concept which you would already be knowing from your understanding of laws of motion is momentum is always given as product of mass and velocity. That's it. Apart from this, the question doesn't have to do anything else with momentum. So how to say the change in momentum suffered by the body, how to find it? Well, let us say initially, what was the velocity? It was u with an angle alpha. And they're asking at the instant or at the highest path, what would be its velocity? It would be simply u cos alpha. What we know is its a horizontal component never changes between the point of projection A and the maximum height B. Horizontal component never changes. So what component actually changes? It is only the vertical component, which is u sine alpha. At A, the projectile has u sine alpha y component, but at B, the y component velocity along y is 0. So change in momentum will not be along the horizontal, but it will always be along the vertical because horizontal component of velocity didn't change. It was only the vertical component. So what was the change in the vertical component? It is final value is 0, initial value is u sine alpha. The difference between them is u sine alpha. Therefore, the change in momentum is mass times the change in velocity, which is u sine alpha. See, so the answer should be mu sine alpha. How did we do it? We simply said that the horizontal component doesn't change during the course of a projectile journey. It is only the vertical component. Final vertical component is 0. Initial vertical component is u sine alpha. The change should be u sine alpha. I multiply it with them and I get um, the magnitude of change in momentum. Is there any easier way to do this? Yes, of course, there's an easier way, a 1 minute way. What I do is I will put alpha to be a 90 degrees. If I put alpha to be 90 degrees, then what I am really seeing is a vertically thrown upwards ball. So at the highest point, its velocity becomes 0. At the lowest point, its velocity is u. So what is the change in momentum? It should be simply mu. So if I put alpha as 90 degrees in the options, I should get mu. This is always mu, regardless of the choice of alpha, this is always mu. So this is eliminated. This gives 3 mu, eliminated. If you put alpha as 90 degree, this gives you 0, eliminated. Hence, the only choice is mu sine alpha. This would be a better way when you don't know about the components and stuff like that. You simply put alpha as 90, convert the projectile to straight line motion, a vertically thrown upward, a vertically upward thrown ball or something. So it would be mu sine alpha would be the answer. Now we'll go to the third one. Third one hasn't to do much with any concept as such. It is based straight away on a horizontal projection formula. So we note that whenever a body is projected horizontally with speed u and it lands on the ground, that range, the distance from the base of that tower to the point where it lands, this range is always given as u times square root of 2h by g. This is a standard thing. U times square root of 2h by g, where u is the horizontal speed, h is the height from which the bomb or the ball has been thrown horizontally, and g is acceleration due to gravity. So here u is given as 216 kilometer per hour and h is given as 1960. Well, uh, look, here it is 1960, right? So should I be considering G as a 10 or should I be considering G as 9.8? There's a subtle hint involved here. If you consider G as 9.8, you see 9.8 times 2 is 19.6. So 1960 can cancel with, say, the G down. But if you put a G as 10, you might be not be able to cancel the 1960 part very wonderfully. So better to take G as 9.8 over here and U is 216 kilometer per hour. Look at the final answer. Everything here is in terms of kilometers and this is in terms of meters. Well, better to convert 216 kilometer per hour to meter per second by multiplying with 5 by 18. Solve it. Whatever you get, it will be in meters. Then look at the options and say which is the which one of them satisfies the kilometer conversion, right? So that would be the third one. It's a lengthy one, but of course it's worth it because it is a formula based question. U root 2h by g, the range for a horizontally thrown projectile. Now we go for question number 4. A projectile is given an initial velocity of I plus 2j. What is the Cartesian equation of its path? Well, I plus 2j, if I look at it carefully, it is 1 meter per second in horizontal and 2 meter per second along the vertical. If I join the tail of one vector to head of the other vector, the magnitude of the initial velocity turns out to be root 5 and the angle which comes out to be is tan theta equal to 2. So what information do I get it here? I get to know tan theta as 2, the initial velocity as root 5. That's all I need for the Cartesian equation, which is the equation of trajectory. Y equal to x tan theta minus half gx square upon u square into 1 plus tan square theta. I put tan theta as 2 and u as root 5 and I'm done with it. That is question number 4. Now question number 5. For the projectile, the ratio of a maximum height reached to the square of time of flight is, well, if you are a guy who is comfortable with formulae, here it is. This is nothing but they're asking h by t squared value, right? H formula is given by u square sine square theta upon 2g, whereas t value is given by 2u sine theta by g the whole square. You look at it, you see the u square sine squares and the u square sine squares, the g square, right? The there is a g term which will not cancel, right? And then there is a 2 square term coming up. If you simplify, you would get around 5 is to 4, right? This is straightforward. Height formula, you know, T formula, you know, you divide them, you cancel the U's and the signs, you will be left with the numbers and the G's. Simplify, you'll get 5 to 2. They have given, take G as 10 though, so you'll get the exact ratio. That is question number 5. If you're not the guy with the formula, if you're somebody who wants to do it without the help of a formula, here it is. For the same question, what I do is, I will consider the second half of the projectile, the journey from the maximum height to the ground, the second half. How much time will the projectile take to cover this second half? It will take half the time of flight. And what is the initial, if I take this as starting point of the journey, what is the initial y component? It is 0. Reason, at the maximum height, the projectile doesn't have a vertical component, it has only horizontal component. And what is the height here? The height is maximum height h. So in the y direction, I apply using sign conventions. Initially, it was at the top. Finally, it's at the bottom. So minus h is equal to uy is anyway 0. So you get 0 minus half g. The time is t by 2 the whole square. So here I get to calculate, we get to know that h is equal to 5t square by 4. So take t square to the other side, you get again our hero 5 to 4 as the answer. So if you're the formula person, go for the formula. If you want to look at it and appreciate the beauty of the situation, it's a consider the second half of the projectile journey. And now we go for the next question, question number 6. After 1 second, the velocity of a projectile makes an angle of 45 degree. After 1 second, it is traveling horizontally. What is the magnitude of initial velocity of projection and so on and so forth? Very good question. They are telling after 1 second, the velocity makes an angle of 45 degree. After one more second, it's traveling horizontally. We ask ourselves, when will the projectile travel horizontally? Only at the maximum height. Indirectly, they are telling that for the projectile to get to the maximum height, right? It takes a total of 2 seconds. At 1 second, somewhere in between, it was spotted with 45-degree cutting. Now, at the maximum height, its velocity became horizontal. So, how much from the beginning till the maximum height it took time? 2 seconds. If it took 2 seconds to the maximum height, how much more it will take to reach the ground? Another 2 seconds. Right? The time taken by the projectile to reach the maximum height is the same as time taken by the projectile to reach the ground from the maximum height. So the total time here comes out to be 4 seconds. And guess what? That is time of flight. 4 seconds. What is time of flight? Time of flight is 2 times vertical component 2u sine theta. U sine theta nothing but initial vertical component by g. That should be 4. If I solve this equation, I get initial y component to be 20 meter per second. Right? With this itself, I can eliminate few options. Reason, if the initial y component is 20, the initial velocity or the speed should be greater than 20. Why? Because let this be the initial speed. The vertical component itself is 20. Therefore, the hypotenuse should be, or the magnitude of this velocity should be greater than 20. Here I see that 14.02, 14.62, both of them are less than 20. I eliminate them. So either it should be D or B. The only thing is I need to find the angle now. How do I find the initial angle of projection theta? This is something which will involve few subtle details. So we will go with the first data. It makes an angle of 45 degree with the horizontal after 1 second. So what I know is after 1 second, it makes an angle of 45 degree with the horizontal, right? Its vertical component never changes. It will be ux. Horizontal component will be vy, some component. What is vy? Vy is uy, initial y velocity, minus gt. G is 10. At what t I'm observing it to be 45 degrees? At 1 second. So I get to know that vy equal to uy I found out 20. 20 minus 10, which is 10 meter per second. So I found out at this instant of time, the vertical component has become 10 meter per second. But according to trigonometry, the perpendicular should be equal to the base. So the base also is 10. Hooray, I got what I needed. I found out the initial horizontal component and I already know the initial vertical component is 20. What's there? I can simply find the angle now. How? Initial horizontal component is 10. Vertical component is 20. I complete the triangle. Tan of this angle is opposite by adjacent. Tan theta turns out to be 2. So theta is tan inverse 2. So the only option that is now left out for us is not 60 degrees, wala. It should be B. See, I did not bother to find out the exact value of the speed. I just got to know 20 meter per second is the y component and the actual speed should be greater than 20 meter per second. So 14 points were eliminated. I found out the angle easily by this logic. The logic happens to be at the instant, at t equal to 1 second, both vertical and horizontal component is same. Horizontal component never changes for a projectile. So vertical component by v equal to u plus at turns out to be 10. Even horizontal component should be 10. Therefore, the initial vertical component is 20, horizontal component is 10, and I found out the angle as 2. So that's a nice question. Right? Question number 7. Again, innumerable number of times h by r. how to relate when theta is given. H by R is tan theta by 4. Tan of 45 degrees is 1. Tan theta by 4 turns out to be 1 by 4. So H by R turns out to be 1 by 4. So R should be equal to 4H. The only right option turns out to be C. Now, question number 8. A projectile can have the same range R for two angles projection. If T1 and T2 be the times of flight in these two cases, then what is the product of the times of flight in each of these? Well, for the eighth question, it demands some, more data. I'll just fix screen for you. Well, um, it has same range R for two cases. One is for theta, other is for 90 minus theta. The speed in both of them is u itself. Okay. So what we do is we know that horizontal range is equal to horizontal component times time of flight. The same range for the second one is cos of 90 minus theta, and corresponding time of flight is T2. The horizontal range is equal to horizontal displacement into time of flight. Okay. Now, they're asking what about the product of T1, T2? So I multiply both equations. R square is equal to U square sine theta cos theta times T1, T2. But remember something. What is sine theta I mean, u square sine theta cos theta. If I multiply by 2 and divide by 2, you see this turns out to be u square sine 2 theta, because 2 sine theta cos theta is sine 2 theta, right? U square sine 2 theta. And that is nothing but the range formula, which you are getting somewhere over here. And this range cancels with this one of the ranges in the LHS. So the product of the times of flight turns out to be proportional to just the range. Okay. So the question number 8 goes with just the range R. Next one. For ninth one. For a projection, range square is 48 times of height square. Again, range and height. So we h by r equal to tan theta by 4. So h square by r square equal to tan square theta by 4 is simply squared for my convenience. R square is 48 times h square. So this becomes 48 times h square cancels. Okay. And then this 4 goes with 48 as 12. And then I find out the value of tan theta. Okay. Or if you want to find the say with the traditional way, uh, they have given r square equal to 48 times h square. You take root on both sides. R is equal to root of 48. Root of 48 is 4 root 3 times h. R becomes 4 root 3 times h. Then do h by r becomes 1 by 4 root 3. And that is exactly the first question which we did, where the range was 4 root 3 times maximum height. Remember the very first question in our discussion now. So it should be 30 degrees. Right? So you see the same question has been repeated twice, but the wordings have been different. That's wonderful. Now next, a ball thrown by one player reaches the other in 2 seconds. What is the maximum height reached by the ball above the point of projection? Well, um, what we can say here is they have given the time of flight. Time of flight t is equal to 2 times vertical component by g. T is given as 2. The 2 cancels with the 2, and I get the initial vertical component as 10. After getting initial vertical component, how will you get how will you get max height? Maximum height is u square sine square theta by 2g, or I can say uy square by 2g, initial vertical component square by 2g. So 100 by 20, which gives me around 5 meters. So the answer is 5 meters. Next one, the 11th one. The three particles ABC projected so same initial speed, the keyword 30, 45, 60. Whatever is thrown with 45, that will have the maximum range, whereas 30 and 60 are complementary angles, so they will have the same range. So the most appropriate answer would be range of A and C are less than that of B. It can't be greater than that of B, because B has a maximum range, so C isn't right. So most appropriate is B. Next, two vectors A and B at an angle of 60 degree with each other. The resultant makes an angle 45 degree with A. If B mod B is 2 units, then what is mod A? This is a typical example of how formulas can save the day. The resultant makes an angle of 45 degree. We immediately relate tan alpha equal to B sine theta by A plus B cos theta. I put alpha as 45 degrees, theta as 60 degrees, and the mod B is 2 units, it seems. So this will be going as 2 cos theta, sin theta would be root 3 by 2, cos theta is 1 by 2. The only unknown is A, and that's what we will find out. So just one formula. Tan alpha is B sin theta by A plus B cos theta. The angle which the resultant vector makes with the B is given as like this. So that is, with A is given like this. So that seals the challenge level of the problem. Next one. The simple sum of two co-initial vectors is 10 units. Their vector sum is 8. The resultant of the vectors is perpendicular to the smaller vector. What are the magnitudes of the two vectors? So what we do is, the resultant of the two, let's say it is vector A and vector B. The resultant of two of them would be this. The resultant is now perpendicular to one of the vectors, right angle triangle. And they are saying vector sum is 8 units. So the magnitude of this perpendicular is 8 units. Well, they're asking what are the, uh, uh, you know, uh, magnitudes of the two vectors. They want what is A and what is B. One thing is, if I use Pythagoras theorem, I can say B square minus A square. B square minus A square should be square of the perpendicular, which is 64. Which of the options gives B square minus A square as 64? Well, the only option that gives is C. There is a typo here. It is not 10 units, it is 16 units. 10 plus 6, 16 units. So what information they have given is A plus B, just the sum of the magnitudes of the two vectors is 16 units. Vector sum, the magnitude of the vector sum of A and B is 8. With this information, I need to find magnitudes of A and B. Well, by looking at the triangle, B square minus A square is 64, the only appropriate option is 6 and 10. Next, if sum of two unit vectors is also unit vector, then what is the magnitude of their difference? Okay, so, well, what we do is this. First, we find out the angle between two unit vectors. One unit vector, other unit vector, third unit vector. The situation is something like this. This is the resultant. These are the individual vectors A and B. Why is it called a unit vector? Because the length of the arrow is 1. What triangle is this? This is an equilateral triangle. So the angle between the vectors, the exterior angle is 120 degree. Reason, inside the equilateral triangle, it is 60. So outside it should be 120. With this information, how can I find the difference? We know the difference between two vectors can be written as A square plus B square minus 2AB cos theta. Not plus 2AB is for the sum, minus 2AB is for the difference. Now I put A, B as 1 each because magnitude of A and B are 1 and theta to be 120. So I get 1 square plus 1 square minus 2, 1 into 1 into cos 120. Remember, cos 120 is negative half, minus 1 by 2. So with this, I can say root 3. Right? 2 minus 2, 2 minus 1 is plus 2. Plus 2 goes with the 2 as 1. 1 plus 1 plus 1 is root 3. So the answer should be root 3. Here we didn't do much of algebra. We just knew that if the sum of two unit vectors is a unit vector, then they should be an equilateral triangle arrangement. The angle inside angle is 60, so outside angle is 120. Then we use a difference formula and we got root 3 over here. Next, the 15th one. A force is inclined at 60 degree. Horizontal component is 50. What is the magnitude of the force in vertical direction? All right. So horizontal component is 50, vertical component I need, and the force is inclined at 60 degrees. So tan 60 is equal to y by 50 or y is equal to 50 root 3. This is a question from resolution. It tests your understanding in resolution. Y equal to 50 root 3. 50 times 1.73 something. So it should be around 87 newtons. If you plug in root 3 as 1.7 approx, you will get around 87, right? The diagram saves the day. Know much algebra. You should know how to place vectors and construct triangles. Next, a 150-meter long train is moving with uniform velocity of 45 kilometer per hour. What is the time taken by the train to cross a bridge of 850? What we do is we will represent the head of the train by the red line and the bridge by 850, right? Initially, the head of the train is at this left side. After completely crossing, the head of the train would be over here, whereas the entire train length, 150, would be here. This is the instant when the back end of the train is at this side. That is the instant when I see the train has completely crossed. So what is the total distance traveled by the head of the train? 850 plus 150, that is 1000. The distance is 1000. And what is the uh, speed? 45 into 5 by 18 you do. Kilometer per hour is given, convert to meter per second because answer is in seconds. So that is when I realized that the distance is 1000 and speed v is 45 into 5 by 18. That if you take 5 factor, okay, so it would be around 7.5 meter per second. And then you take the ratio of both of them. Time is a distance by speed. So you get the answer. That is about the 16th question. Now the 17th one. A particle moves along x-axis in a way x varies with t as this much. What is the initial velocity of the particle? Well, I just compare this equation with s equal to ut plus half at square. The coefficient is of t is -5. Hence, the initial velocity is -5. A particle has initial velocity of 3i plus 4j. Acceleration is 0.4i plus 0.3j. What is the speed after 10 seconds? Well, here is where a slight improvisation is needed in question number 18. For 18, we all are familiar with v equal to u plus at. What I do is I will simply convert everything to vectors. So final velocity vector is initial velocity vector, which is 3i plus 4j, plus acceleration vector, which is 0.4i plus 0.3j, and I multiply it with 10. T is 10. I collect all the I components together. 0.4 into 10 is 4, 3 plus 4 is 7i, as well as 4, a point into 10 is 3, 4 plus 3 is 7j. So I get the final velocity vector as 7i plus 7j. But they're not concerned about velocity vector. They want its magnitude because they're asking for speed. How to find the magnitude from this information? 7 to the x, 7 to the vertical. So the magnitude is square root of 7 square plus 7 square. That would be around 7 root 2. So the answer for this question would be 7 root 2. B. Now the 19th one. The velocity is given as this. What would be its displacement? Here we remember the almighty flowchart XVA. They have given velocity, they're asking displacement. So I need to, from velocity to displacement, I need to integrate once. If I integrate each of these, okay, look carefully at ft square. Ft square ka integral by golden rule becomes ft cube by 3. ft cube by 3. So in the options, the coefficient of f should be 1 by 3. Which of these has coefficient of f as 1 by 3? It is only B, hence the right option is B. Now question number 20. Two cars A and B are at the same point initially. If A starts with so and so, when will the B catch it? Well, whenever two or more bodies are involved, we always use the approach of relative velocity. So here is where I look at B, I look at A from the perspective of B. B was at rest initially. So it will see A moving towards the right with 40 meter per second. But you see, B is actually moving with an acceleration of 4 meter per second square. So what will B see? B will see A moving back with an acceleration of 4 meter per second square. It moves back with an acceleration of 4 meter per second square because it is moving front. A should move towards the back. So acceleration of A according to B will be backward 4 meter per second square. Cool. Now, what will happen? According to perspective of B is fixed. A will move forward. But remember, acceleration is backward. So its speed will be reducing. And then it stops. It won't. For a jiffy, it stops. Then it has acceleration. Still remember, it comes back. And again, it meets B. This is a time which is being asked the question. After how long will B meet A again? Right? So A will, according to B, A will initially slow down, stop, and then speed up and turn backward. Which motion does this resemble? Let us just tilt this vertically and we'll see that B is standing here, A is moving up, initial velocity 40, but there is an acceleration downwards. I can call it a new G, some planet, okay, new G, where G is 4. It's kind of a new version of a G, 4, where it's going up, stops, and then again comes back and meets B. Now we know the formula for this time of flight of a vertically thrown upward ball with u equal to 40 and g, right? It is t equal to 2u by g. U is 40. G is not 10, remember, G is now 4 because acceleration pulling back is 4. So when I plug in the numbers, I get 20 seconds as the answer. The time would be 20 seconds. I didn't do much calculation here. I took well-established formula of 2u by g, and then I looked at A from the perspective of B, and I tilted the whole picture vertically. It was on a horizontal level. I tilted in the vertical level. Nothing changed. It is it is just like a ball thrown. A is thrown up with speed 40, but it is pulled down constantly with 4. It will go up, stop, and then come down and meet B. So this is question number 20. Question number 21. The slope of the AV graph is given. They're asking what is the slope of velocity displacement curve. In other words, they're asking what is dV by dx. How are the two related? Slope of any graph is dy by dx. Y coordinate is v, x coordinate is x itself. So dv by dx is being asked. What information is given? Acceleration is given in terms of velocity. How can I represent it? We know acceleration, a velocity graph is a straight line. Acceleration is directly proportional to velocity, or acceleration is k times v, where k is some constant. At the same time, from kinematics, we also know how do I relate A with dV by dx? A is V dV by dx equal to kV. The V's cancel on the both sides. I get dV by dx as k. Isn't that what we needed? dV by dx is the slope of velocity displacement curve, and I got it to be a constant. Hence, the answer is C. Now let's go to question number 22. A particle moving in a straight line covers half the distance with 3 meter per second. Other half of the distance is covered into equal time intervals 4.5 and 7.5. What is the average speed of the particle during this motion? Wherever there is half the distance involved, I will take simply 2 meters. The distance would be considered as 2 meters. First half would be 1 meter. 1 meter was traveled with a speed of 3 meter per second. The next half of 1 meter is traveled in equal time intervals. That in the first time interval, the speed was 4.5. In the second time interval, the speed was 7.5. So what is the distance in the first time interval? 4.5 t. What is the distance in the second time interval? Speed into time, 7.5 t. And what is the sum of the two distances? 1 meter. From this, I get to know that 7.5 plus 4.5, what the values I have given, the 13t is 1, or t equal to 1 by 30. right? Why is this useful? Let us see. Now, how do you find the average speed of the entire motion? Total distance traveled. Total distance traveled is 2. I have taken distance as 2. Total time. Time spent in the first half is distance by speed gives you time. So time spent in the first half is 1 by 3. So first half it spends 1 by 3. Second half it spends t and t, totally 2 t's. T is 1 by 13. So 2t becomes 2 by 13. So you solve this uh, equation, you solve this fraction, you get the speed, average speed magnitude. Okay, so the trick is whenever you have one half the distance, you take the entire distance is 2, doesn't matter. First half will be 1, next half will be 1. Equal time intervals, take t and t. Get the value of t by the condition that 4.5 t is the distance traveled in the first half. 7.5 t is the distance traveled in the second half. Some of them should be 1. Now going forward for the 23rd question. A body falling freely under gravity, distance is covered by first, second, and third minute. Any consecutive time intervals, Galileo Galilei has proved it once and for all from his inclined plane experiments that it shall and will always be the ratio of consecutive odd numbers. So the 23rd question, distance is covered in equal time intervals under free fall is 1 is to 3 is to 5. Now question number 24. In question number 24, we have the net displacement and average speed. What is a net displacement of the cyclist? He comes back to the initial position. Net displacement should be 0. So either it is A or D. How do you find the average speed? Average speed is the total distance traveled, right? And by the total time. That's what it is. Total time is 10 minutes. Total distance traveled. You see, this is 1/4 the circumference of a circle. So 1/4 circumference of circle would be around pi r by 2, where r is the radius of the circle is 1 kilometer. So let us say it is pi by 2 kilometers. So this distance is pi by 2 kilometers. And we very well know when the distances add up, 1, 1, and this, it will always be an irrational number because total distance traveled would be 1 plus 1, which is 2 plus pi by 2. Total distance is always an irrational number. So when you divide an irrational number with a rational number like 10 minutes, 10 minutes, you're never going to get a wonderful number like 1. Instead, you will be getting something in points. So D is the right option. You can either calculate it fully and then answer D, or just see that pi by 2 is a fraction or an irrational number. I can't get 1 with this combination, so it should be D. Question number 25. In question 25, it is S is equal to UT plus half AT square. So 40 is equal to U times 5 plus half A times 5 square. First equation. Second equation is 65 meters in the next 5 seconds, right? So what is the total distance traveled from t equal to 0? 105 meters. U. And what's the total time passed? 5 seconds, 5 seconds, totally 10 seconds. U into 10 plus half A into 10 square, which is 100. With this, I have two equations and two unknowns I need to solve for U. Please check which of them would be appropriate. Question number 26. A car is traveling at 72 km per hour and is 20 meters from a barrier when a driver puts on the brakes. Well, it's all about converting first 72 into meter per second. 72 into 5 by 18. It is going to be 20 meter per second. So what we have is U is 20 meter per second and the time value is 2 seconds. And they're asking what is the magnitude of the deceleration and what is the distance traveled till he hits the barrier. S is equal to 20. They're asking what is the value of A. Well, S, U, A, T. The only equation that involves all of this is S is equal to UT plus half AT square. You plug in the values, you will get the options. Question number 27. A body starts from rest and moves with uniform acceleration. Well, uniform acceleration. And you are being given all VT graphs. VT graph, how will you link with acceleration? It should be a straight line. Well, this is wrong. because it's saying velocity is constant. This is wrong because initial velocity is not zero. This is wrong because the graph is not a straight line. Slope has to be constant. So the only option left is 27B. It has to be a straight line and it has to start from zero because starting from rest, it is starting from zero. Question number 28. What is the ratio of the velocities if displacement time graphs are given? How do you link displacement time with velocities? Well, slope of displacement time gives velocity. In other words, V1 by V2 is tan theta 1 by tan theta 2. What is tan of theta 1? Tan of theta 1 is tan 45 degree, which is 1. Tan theta 2, let us say, is tan 31 by root 3. Either the option should be root 3 is to 1 or 1 is to root 3. The appropriate one is 1 is to root 3 as listed in option A. Question number 29. A particle is moving in a straight line path with constant acceleration directed along the direction of instantaneous velocity. So you imagine a car which has put on accelerator and it started from this point. Is it ever going to turn back? It is not going to turn back because for turning back, it has to first come to a stop. It can't happen because it's continuously under accelerator. So a particle may reverse the direction of motion is false. Next, distance covered is not equal to magnitude displacement. That is also false because uh, at any instant of time, if you freeze the car, this is a displacement and that would be the same as distance. Magnitude and distance both are same. The second statement is also false. I won't read the third statement because I immediately look at the fourth statement that all of the above are false. So it should be D, right? So A is false, B is false, C should be false. Otherwise, there is no other option which justifies A and B is false. So D is correct. Now, question number 30, the last question for the paper. A body is moving in a straight line as shown in VT graph. What is the displacement and the distance? I just have a look at the graph. I see that we know this displacement is always lesser than the distance. Reason? For displacement, we calculate the area as negative. For distance, we add the all areas without considering the negative part. So displacement should be lesser than distance. Which of the options have displacement lesser than the distance? Displacement is the first number, distance is the second number. Where I can find distance first number to be lesser than the second number? Is first number less than the second number? Yes. First number less than the second number? No. First number less than the second number? No. First number less than the second number? No. So the only option that seems wise to take is the first option. I didn't bother to calculate the area. This is how you go from the options to the question. I just know that displacement has to be less than the distance. From the options, I pick up only those where the first number is less than the second number. Fortunately, there are no other choices other than A, which is suitable. If at all the examiner was clever enough to put all four options such that the first number is less than the second number, you calculate the area bounded because they're asking displacement. Displacement is simply area bounded, but with considering the sign convention. The area underneath the x-axis is negative. If they ask distance, you calculate, you have anyway calculated the area. You simply add them all up without considering the sign. That would be distance. So the right option for this, appropriate choice for this is option A over here. So this is our discussion. We have tried to discuss the most time economical approach for each of these. For some of them, I have given a conceptual thing as well, how to look at it in a different way and try to get the fun and beauty of the question. So I hope you have got some clear idea about how you would have managed the exam better and made note of the options to question approach, the time solving techniques discussed in the video. Thank you very much. Have fun doing physics and surely you will love physics. Take care till we meet the next time. All the very best.